If you've ever had to build a seed pixel matrix by hand, you already know how frustrating it can get. Sagging wires, uneven spacing, power issues, and a lot of time just spent trying to make it look clean, and honestly, it never really does. Earlier this year, I showed a small prototype PCB designed by Bob Kojma, also known as Bong69. After spending more time with it, I can honestly say this is one of the cleanest solutions I've ever found in seed pixel matrices. Now, I want to be really clear and upfront about something. Bob didn't design this board just to sell it. He designed it to share it. This is an open source design that anyone can download and have made themselves. That's actually what made this collaboration with PCBWay such a good fit, because they're the piece that helps turn an open source design into real, physical, tangible board you can actually build with. Now, when I ordered this from PCBWay, I've never ordered any type of PCB board ever. I don't know how to do it. I didn't know what it took. And so I read the directions online and it looked pretty simple. And so that's why I partnered with these guys. I recorded the entire ordering process, from uploading the files to selecting board options, and you can see exactly how PCBWay handles everything. So I downloaded Bob's design, and when I downloaded it, it was as simple as just going to PCBWay and uploading the design. Once I uploaded it, it asked me a couple questions, kind of what color do I want it? Do I want it a shiny finish? Do I want it a matte finish? And when I picked those couple options there, I went and paid for it and then sent it, and next thing you know, it all showed up on my doorstep. It was really easy. I was a little intimidated because, again, I've never done this before, and now I've done it. I can make any PCB board and I can send it off and have it made with confidence. So don't be afraid to do it. It's super cheap too, like way cheap. You get a bunch of these for next to nothing. Let's talk about the board itself. It's super compact. It's about 1 inch wide and just under 1 foot long. And it's laid out perfectly for 5 centimeter seed pixel spacing. And after talking with him, he redesigned it and made 2 boards available for us to download. Both of them look great, just depending on what you want to do. Each board runs 3 loops of pixels. The traces carry power all the way down the length of the board. That gives you built-in power balancing without having to inject power every few feet. That right there is one of the biggest differences compared to hand wiring everything. Instead of power falling off as you move down the line, this board keeps things consistent from the first pixel all the way down to the last pixel. There's no weird dimming, there's no chasing voltage issues, and the board, it just handles all of that. When I first started working with this design, I built a small prototype just to get the feel of how it behaved. Soldering seed pixels onto this layout is about as easy as it gets. Everything's spaced out, everything's clearly labeled, and nothing feels cramped. You don't need fancy tools either. Take your time, make solid solder joints. One thing I really love about Bob's design is how forgiving it is. You've got a weird gap or a tight spot, you can actually cut the board to the length that you need and keep going. There's cut marks that are labeled out on the board, and that works out perfect. So if you don't need the full foot and you want something shorter, or your garage matrices or your window matrices aren't exactly the same length there, you can cut this board and get it all soldered together and it still works perfect. It's great design. For mounting, I kept it simple. You can do yours different. There's holes that you can screw in or that you can use different types of fasteners. I just use 3M double-sided tape, no drilling, no screws, and it's held perfectly for this test. This setup is eventually going to scale up over my windows and my shutters outside, but this prototype already gave me a really good idea of how the full system is going to behave. This is the part that a lot of people miss. Power travels all the way down the PCB. That means your pixels stay bright and even from start to finish. There's no voltage drop, no injecting power constantly, and the board basically solves this problem for you. And here's the final prototype all lit up. Everything's bright, everything's even, and the board keeps everything really aligned nicely. This is exactly the clean look that I was going for. A couple quick questions I know I'm gonna get. First, Waterproofing. You're not going to make this thing fully waterproof, but you can protect it pretty well from the elements. What I do is I use silicone or liquid electrical tape on all the connection. It goes a long way, especially if it's going outside. I found that works out perfect, works out great. And we're not preparing for the flood here. We're just trying to keep moisture and water off of those connections. And this does a really good job with it. So second would be scaling up. Yes, these boards link together. That's the whole point. That's why I'll be using them across my entire window setup. I made it a foot and I want to add another foot and I want to add another foot. And let's just say I build a 3-foot section this year and next year I'm going to add 2 more feet to it. I just tag it onto the end of the board. It's a fantastic setup. So scalable, yes, it's great for that. If you want to build one of these yourself, you can download the design files and have them made. I'll have the links down below. Thanks for watching Twinkle Tunes and Lighting, and I'll see you on the next one. Now, click some videos. I'm off to the middle, so you can click the subscribe, and then here's a couple. There's a video over here, and there's one over here. Click these videos and watch them. They're awesome. I'm gonna build a shutter matrix. It's gonna be huge. I like it. All out of seed pixels. 5 volts to be exact.